All right, in the earlier lessons we talked about the special angles that were 30 degrees, 45 degrees, and 60 degrees, or their radian equivalent. And now I want to talk about what are called quadrantal angles, or I just call them quadrant angles. And these are angles that fall on an axis. And so, just an example of the first, in one rotation, the first four quadrant angles would be 0. This would be 90 degrees, or why don't we write them in radians? Pi over 2. This would be 180 degrees, or pi. And this would be 270 degrees, or 3 pi over 2. So, since the new definition that you were given of trigonometric functions of any angle was based on an ordered pair that was on the terminal side of the angle, we could use any ordered pair that's on a terminal side of an angle and we'd get the same trig ratio. Remember, trigonometric functions are functions, and so that for every input there's only one output. So what we're going to do here is we're going to use what we call a unit circle, or a circle with a radius of 1. So if the radius of this circle is 1, I'm going to put an ordered pair on the terminal side of each of these quadrant angles. So if the radius is 1, think about what the ordered pairs would be. Pause the video for a moment and see if you can fill in the four ordered pairs if this circle had a radius of 1. So at 0 degrees, that ordered pair, we'd go over 1 and we would not go up or down, so that would be 1, 0. At 90 degrees, our x-coordinate is 0, but our y-coordinate is 1. At pi, or 180 degrees, our ordered pair would be negative 1, 0. And at 3 pi over 2, or at 270 degrees, our ordered pair would be 0, negative 1. Alright, so let's look at the sine of 0 degrees using the x and the y coordinates. And again, we know r is equal to 1. So the sine of 0 degrees, well, it's going to be y over r. And the y coordinate at 0 degrees is 0. R is equal to 1. So that's equal to 0. The sine of 0 is 0. Now, just to stress the fact that it really doesn't matter how big or small the circle is, that if I drew a circle, say with the radius a half, that the ordered pair on the terminal side would then be 1/2, 0. But the y over r would still come out to be 0, because y would be a 0 and r would be a half, and I would still get 0. So I just want to stress the fact that it doesn't matter how big or small the circle is, the trig functions are going to remain the same. Alright, so let's get back to our circle that has a radius of 1. And let's evaluate our trig functions. The tangent of 90 degrees. Tangent is y over x, and so at 90 degrees, my x is 0 and my y is 1. So the tangent is going to be 1 over 0, or that would be considered undefined. The cosine of pi is x over r, and x is negative 1. R is equal to 1, so the cosine of pi is equal to negative 1. The cosine of 0 is, again, it's x over r, but we are now using this ordered pair right here. So the cosine of 0 is going to be 1 over r, which is 1 over 1, or just 1. The cosecant of 90 degrees, well, the cosecant is 1 over the sine. The sine would be y over r, so it would be 1 over 1, and the reciprocal of 1 is just 1. The cotan of 3 pi over 2, we're going to look at the ordered pair 0, negative 1. That's on the terminal side of 3 pi over 2. The cotan is x over y, and so the cotan is going to be 0 over -1, or just 0. So we've got the two special triangles, the 45, 45, 90, and the 30, 60, 90, and those help us generate the trig functions of those special angles. And now we have another, you could call this sort of a trick, that we can generate the trig functions of any quadrant angle using the ordered pairs 1, 0, 0, 1, -1, 0, and 0, -1. And this doesn't matter how many times we rotate around this circle. If we were going to talk about 360 degrees, well, we'd be right back at 0 here. Or 2 pi, we'd use this ordered pair right here. If we were going to go around one rotation 360 degrees and go another 90, then we would still use the 0, 1 ordered pair. So what I'd like you to do is pause the video. I'd like you to use the unit circle, or a circle with a radius 1, and those 4 special points or ordered pairs to help you generate the trig functions of these quadrant angles. Alright, so I've quickly drawn the 4 ordered pairs to help me. Sine of 180 degrees, I know that sine is y over r. I'm using a radius of 1. So I'm at 180 degrees right here. And so y over r is going to be 0 over 1, or just 0. I'd like to do the cosine of pi. I'm still using the same ordered pair. Ordered pair is -1, 0. Cosine is x over r, which is going to be -1 over 1, which would just be -1. The tangent of 3 pi over 2, we're going to use 0, -1. That's the point on the terminal side of 3 pi over 2. Tangent is y over x. So it's going to be -1 over 0, which is undefined. The cosecant of 90, that's going to be 1 over the sine of 90. The sine of 90 is going to be y over r, which is 1 over 1. And the reciprocal of 1 over 1 is still 1 over 1. So this would just be 1. The secant of 0 would be 1 over the cosine of 0. The cosine of 0 is x over r, which is 1 over 1. And again, 1 over 1, the reciprocal is 1. And last is the cotan of pi over 2. Cotan is 1 over the tangent of pi over 2. The tangent is y over x. So this is going to be x over y. So at pi over 2, I'm going to have 0 over 1, which is just equal to 0. Alright, I hope you did well on these. I'd like you to pause the video again and answer a few more questions, and then start the video to check your answers. And then I'm going to show you a video on another kind of a quick way to help you remember the trig functions of special angles without a calculator. Alright, let's look at the first one. State a trigonometric function whose value is undefined. Did not use any of the functions used in the problems in practice 2. So try and come up with your own. And so the first one, if I want something to be undefined, I want the denominator to be 0. So if I just choose a denominator of 0 and then just choose a numerator and find the ordered pair that would work for that. So if I did -1 over 0, well, -1, 0 is a point right here, and so -1 would be the x, and 0 would be the y. And so since I'm at pi here, x over y is the cotan, so cotan of pi would be undefined. let's look at a trigonometric function whose value is 0. So what I would need is 0 over 1 or negative 1. Say we did 0 over negative 1. In that case, that would bring me to this ordered pair right here, 0, negative 1. The 0 would be the x, the 1 would be the y. X over y, again, is cotan. That would be cotan of 3 pi over 2. Okay, the last one, state one trigonometric function whose value is negative 1. Do not use any of the functions used in the practice problem 2. So using my ordered pairs, I need to use one that has negative 1. So I would look at something like negative 1 over 1. So if I had negative 1 over 1, I know that r is equal to 1, and if I use the ordered pair from 3 pi over 2, that's a y value that's equal to negative 1. So y over r would be sine. So the sine of 3 pi over 2 is equal to negative 1.